Welcome to today's webinar, Introduction to Text-Based Coding in JavaScript. This webinar is part of the Introduction to Text-Based Coding series and can be viewed in sequential order following the HTML webinar. Special thanks to the Government of Canada for funding this initiative. My name is Danielle, and I'm excited to be discussing JavaScript with you today. Don't forget, if you want to see more of this content, be sure to like this video and subscribe to our MindFuel channel. In today's video, we will continue on and cover some beginning elements of the text-based language of JavaScript. We will explore the basics of JavaScript, some simple actions we can add to get output from JavaScript, reacting to user input choices, how JavaScript makes conditional choices, and we will drop in some prepared code and experiment with customizing it to add some animated fun to our own STEM webpage. We will build off the quick preview that was provided in the previous video in this series, where we added some animation through a button. Then finally again, we will provide a sneak peek of what is to come by looking at a special feature using CSS coding. As a reminder, you will want to have a free open editor ready to practice step-by-step adding in the JavaScript code. You can access the code editor at code.wonderville.org. This is what it looks like. This video can be used to continue to add to your project of the STEM page started in the Introduction to HTML webinar. If you saved your code, you can copy and paste it into the code editor to continue adding to it. Or you can start with the example code that I have here. In the editor, you can access this example code by clicking the menu button and selecting the Click for Example Code button. So let's get started with a little background information on the JavaScript language. HTML got the web started with text, photos, and links, but coders started wanting to do more. Browser makers, such as Netscape and Microsoft, started competing to add features for making better-looking and more active websites. CSS was added to HTML to give more style for better-looking sites, and at about the same time, JavaScript was added for actions. JavaScript is an imperative language used for breaking complex actions into sequences of smaller steps and including all the details the computer will need. JavaScript started small, but quickly gained fans who wanted even more capabilities. Some of those actions coders wanted were interactivity, where the computer reacts to the input from the user to have a kind of back and forth conversation, as well as calculations, using the full power and speed of the computer. And finally, animation, meaning moving and changing the screen display, especially when combined with interactivity and calculations, in a game, for example. So that is just what we are going to do next. Start to add some action into our STEM project page. In the tradition of starting a new computer language with a Hello World message, we will start with a very simple JavaScript program. We are going to add the following to our STEM project page. Again, as of now, our page has only used the HTML code, and typical web pages use a combination of coding languages to bring it to life. So we're going to spice it up with some JavaScript. This line combines HTML, highlighted in yellow, with JavaScript, highlighted in green. So let's start by looking at this code and breaking down what it means. The HTML input tag means we want to display an input control and wait for the human user to do something. In this case, it is as simple as it gets. The type is button, so the computer displays a button control. The value attribute is used to put any text caption you want onto the button. For this example, we have chosen for our button to say Hi JS. Then the computer waits to see if the user clicks the button with their mouse or a tap on a touch screen. if and when they do, the onClick attribute comes into play. The value of onClick, highlighted in green, is very interesting because it is our first JavaScript code. This portion of the code should create an alert message to pop up from our computer. Now let's go over to our Wonderful editor and give it a try. Anywhere in the body section, wherever you want the button to appear, we are going to type in the line of code. Once you have entered it, try running it. You will see a button on your page. Let's click it to see the actions come to life. How cool is that? Our computer is now talking to us. Clicking the button should pop up a box with your message. JavaScript's alert statement is usually used to alert the human user to something important they should do. In this simple example, the user just needs to read the message and click OK. Creating the button with the correct caption and position on the page was all done by running the HTML code. When you clicked the Hi.js button, we got some action as the JavaScript code came into play. Now let's use this simple action to interact with a human who has read your STEM topic page with a little quiz. Think of a multiple choice question you can ask about your topic and make a list of possible answers, with one being correct. For the correct answer, we will want to display a message of congratulations. For the wrong answers, we'll want to show some other helpful message. Here, you can see an example for my Isaac Newton page. I have included my open-ended question of Isaac Newton was a, and then 3 buttons with various options: a cookie, a scientist, or a quarterback. I've also included code for an alert to pop up once my user has made their selection. Let's jump over to our editor to try this out together. Near the bottom of the body section, add a paragraph with your question and a button tag for each of your possible answers. Again, here is my example. Once the code is entered with your own specific question, values, and alert messages, when you're ready, click Run and test out your buttons and their alerts. So I'm going to scroll down, and now you can see I have my question right here with my 3 button options for the answer. Cookie pops up an alert that says Newton was a person to give me a hint that that wasn't correct. Scientist tells me my answer is correct. Now I'm just going to check my final one of quarterback, and wrong Newton, try again. So there you have it. Our multiple buttons and alerts works great, and our page is really starting to come together. Let's see what else we can add. Now that we have a few basics down around the use of buttons and alerts, we're going to focus on some other ways to add actions and change the output to help spice up our STEM page project even more. So output is a very general term used by coders to describe anything our code creates or produces, its end goal. Very often, the end goal is to display something to a human. So, as in our case, anything we see because of our code is considered output. So far, our HTML output is our page, and the JavaScript output was an alert message. So alert dialogues are a quick and simple way for coders to output information, but users get annoyed if they pop up too often. So let's look at some other cool output methods, such as changing what is displayed on the page. Throughout these webinars, we have been making all kinds of changes by going into the editor and typing. Now imagine that I get someone else to make the changes for me. I might tell them, please change the HTML so that question 1 disappears and the correct answer appears in its place. If my helper is a coder, it shouldn't take long. But if they don't know what I'm talking about, then I'm going to have to give them more detailed instructions. Maybe no one wants to do all this for me, but I can also get JavaScript to make the changes. JavaScript can change anything on our page very fast, and over without complaining. However, JavaScript does need every detail included in its instructions, using only words it understands with no mistakes. As a coder, you learn the words JavaScript uses and their exact meaning, and with experience and internet searching, you find out what details you need to supply. However, making no mistakes is an ongoing challenge. So let's take a close look at the code I have added. In green, there is a long JavaScript statement. It starts with document, which is JavaScript's word for the HTML code of our page. Then getElementById means look for. So we want the computer to look for something in our HTML. We want to find question 1, including its answer buttons. Unfortunately, JavaScript doesn't understand that, so we have to give it some help. I have used a div tag with the ID question 1, plus its matching end tag in yellow. Div is short for page division, and it is a type of general purpose tag for dividing the page any way we want. In this case, I used it to tell the computer exactly where question 1 starts and ends, with start and end div tags. So now JavaScript will be able to find exactly what we want. Back in the JavaScript, inner HTML means all the HTML code inside the start and end tags. Finally, in JavaScript, the equal sign means to give something a new value. In this case, a new HTML with the message, Newton was a scientist. That is a lot of detail, but it's what the computer needs. It is just as if we gave a person very detailed instructions on the changes we wanted on our page. With JavaScript, we have to be even more careful with our instructions, but if we get it right, the changes happen very fast. In this case, the changes look instantaneous when we select the scientist button. I have left the other buttons with their original alert statements. We could change them too, but for now, let's give these changes a try. Now that I'm in my editor, I'm just going to add that changing text option right here around my question that we just created. Now that all the code's in, let's click Run, and let's see what happens when I select my scientist button now. My entire question is replaced with correct Newton was a scientist, so my code is working perfectly. Give it a try on your end too. Okay, now that we've added some changing of the text, let's add a bit of color. JavaScript can be used to change many other things about the display. For example, we can add a second line of code to change the color of the divided section we just created. Look at the highlighted code here. Now we have told the computer to add a background color of yellow to the correct message that is displayed when clicking the scientist button. Let's try adding this line to your editor and see what happens. Okay, so I'm going to add in this code right here after my Newton was a scientist JavaScript code. And now I'm telling it to color that answer in yellow. So let's run and let's see what happens if I click my scientist button. So there we have it, a yellow highlight on the word correct, Newton was a scientist. Feel free to play around with your color choice here by simply changing the color name, like so. Let's give it a try, and now it's pink. So pick whichever color you like best for your page. Now I just want to take a moment to dig a little deeper into what we just created. This JavaScript code we just tried out is made up of two statements because we are doing two things, changing the text and changing the background color. A statement is a line of code or action that the computer will execute. Each line is a single step within a sequence of steps. Coding in JavaScript is a process of breaking actions down into simpler steps until each step is simple enough to be written as a JavaScript statement. Knowing what JavaScript statements are available is a combination of practice and searching the internet. In our case, we have two main steps, and I have found two statements that will do everything we want. Statements are usually one per line, but you don't have to do this. To make it the most clear, most coders use a semicolon to end each statement, but that is optional in the syntax. Statements are executed one after another, and even though there are two steps here, they happen so fast it looks to us like everything happens at once. Now let's talk about some ways users can interact more with the page. To a coder, input is the raw material we are given to work with, the information supplied ahead of time in a computer file, or the information a human supplies with a keyboard, mouse, or other device. So let's ask another question about our STEM topic, but this time not a multiple choice. Let's ask a question where the user has to type in the correct answer, and the computer will check it. As I mentioned, JavaScript breaks actions into smaller steps. So we start by breaking this interaction into its main steps. Display the question, wait for the user to type in their answer, and then see if it's correct. Let's tackle the first step by entering HTML to ask the question. On this slide is the HTML for asking another question. Just to keep things organized, I am using a div tag to specify where question 2 starts and ends. We put the question in a paragraph and then display two input controls, a text box where the user can type an answer, and a button to click when ready to check the answer. Looking ahead a bit, I know JavaScript will need exact details, so I have given the text box a name, input year, so I can tell JavaScript where to find the user's answer. I could call it just about anything, but I want to remind myself that this is the input from the user, and I'm expecting them to enter a year. Now I'm not going to assign any JavaScript to the button, so it won't have any action when we try it out, but I just wanted to set up its initial code to see that it has a presence on the page. So let's give this a try in our editor. I'm going to add the code for my new question right here, and again use my div tags, label it my question 2, insert what my question is here, and then add that ability for that text box and a check answer button. So let's run it and see what it looks like. And right here, as you can see, I've now divided my page with the second question, what year was Newton born? I have a text box that indeed I can enter information in. And again, this check answer button does not work yet. I have not assigned it code, but just wanted to make sure that our text box was working. So go ahead and give this code a try and see if you can get a second question to pop up with a working text box. Now I want to go in and add some of that action to that check answer button. So we just saw our question with an input text box and a button, but we have to do more. We haven't told the computer how everything is connected and what action it should take specifically. For this, we need our JavaScript. We need to add onClick to the button and give it some JavaScript code to run. When the user clicks the button, the first action I want is to get whatever was typed in the text box and create an alert message to display. The highlighted code is enough detail for JavaScript to find the text box I'm referring to, get the value that was typed into it, and display it in an alert message with my messaging. I have specifically told my computer to have an alert with the correct answer and then a space for the user's answer as well. Let's try out this highlighted code together in our editor. Okay, so I'm going to add in some of that specific JavaScript code right here to give some of that action to my check answer button. So I've just copied in my code and I'm going to press run. And then I'm going to test out my JavaScript and my text box again. And now I see that my alert, my check answer button is working, and my alert has popped up with the correct answer is 1642 and my answer displayed of 1462. So feel free to give this a try with your second question that matches with your STEM topic project. Feel free to also change what is displayed in your alert. So have some fun experimenting with that. Now we're going to look specifically at the coding term conditionals. This includes if statements and else statements. Or to put it simply, where you use code that enables decision making for the computer. This will help us add another element to our user interaction we just created with question 2 and that text box. So let's jump in and see what else we can do. Instead of us creating the alert message and coding in the messaging around the correct answer and user answer, we can choose a different step where the computer can check the answer from the text box for us by using conditionals or if and else statements. Let's look at the if statement first. A basic if statement is made up of the elements shown in the example highlighted in the slide, a Boolean portion, and a code block section. You're basically telling the computer if something is true, then execute this action. So let's break it down a bit. Boolean, which is found between the round brackets, simply is something that is either true or false. So in our actual code, we are stating if the user input year is equal to 1642 or true and correct, then the computer is to carry out the following action. That action in this case is noted in the curly brackets and tells the computer to alert the user with the message of correct. These JavaScript statements tell the computer that these steps are only to run if the first part of the statement is true. So let's give it a try in our editor to see how it all comes together. So I'm going to delete the code that I added specifically for my alert message, and we're just going to change it up a bit. And I'm going to type in my new code with the conditional. Let's give it a run and see what our conditional statement looks like. So again, what year was Newton born? I'm going to put in the correct answer of 1642 and check my answer with the button. And now I have my alert that pops up saying correct. Now, I'm curious to see if I put in the wrong answer, if anything would happen. What do you guys think? You're correct. We haven't told the computer to do anything if the answer is incorrect or false. Let's just dive a little deeper into what the computer is exactly doing with this code. So the computer's first step is to check if its text box input is equal to 1642. The double equal sign in your code is a comparison operator that checks to see if two things are equal with the result of either true or false. If it is true, if the input text is equal to 1642, then the code block is executed. In our case, when we just did it the first time, the code block contains an alert statement that popped up and said correct because we put in 1642, the correct answer. However, in our second test, when we put the incorrect answer, nothing happened. That's because our Boolean comparison is false. Because I did not provide the correct date, the code block is skipped and nothing happens. So now let's go into that else statement and put some code in for when the Boolean statement is false. So here, if the input is incorrect, we probably want to reply with some helpful hint. Right after the code block, we have the option of adding an else statement. Its code block is only executed, like I said, if the Boolean comparison is false. For our example, if the user inputs the incorrect answer, then I want the computer to give the user an alert saying try again. So let's just go back to our editor and add this little bit of code and give it a try. So I'm going to add my else statement just right here, and I'm going to again create that alert to pop up, sorry, try again. Let's give it a run and test it out. Now with the incorrect answer, I have that alert with sorry, try again. Now give it a try and test out the alerts that you receive from the computer when you provide a correct and incorrect answer for your STEM topic question. It's pretty cool that we coded our computer to make a decision based on our input answer. You can also use a little bit of time right now to check your code to make sure your questions make sense for your topic, that you have good alert messages, and that everything works properly. Remember to test incorrect answers as well as the correct ones. If you have typed everything correctly, then you should have 2 working quiz questions. So feel free to also take some time to continue to play with the code, be creative, and experiment with what we've been working with, as this is a great way to further learn and explore your coding skills. Okay, we are now moving on to adding some animation onto our STEM page. Previously, in the introduction to HTML video, we included some animation with the fetch button. On the next slide, we will add this JavaScript code in again, and this time we'll provide some explanation about how to customize it and take it a step further. So before we jump into adding the animation, it's important to note that it's very common for coders to use the work of others. If you search for what you want to do using what language, you often find many code examples on the web. Some examples are better than others, so you'll have to do some reading and experimentation to find something that will work for you. And it is unlikely that you will find an example that does exactly what you want. You most often will probably have to make some changes. So that being said, in these next steps, we have provided some example code gathered from various resources on the web. Let's go into our editor to try this example code to add in the fetch button we previously were introduced to in the HTML video. Don't worry about digging into the code right here on the slide, as it's already pre-programmed into our editor, and I'm going to walk you through step by step of how to incorporate this code in your editor. For the first step, instead of having to search the web for examples, we have pre-selected some code snippets and provided them for you here in the editor. You can find the JavaScript code snippets by clicking the menu button on the Wonderville editor page and scrolling down. Now step 2 is to select and copy this code, close the dialog, and paste it into the body of your HTML code. Of course, you could always type in the code too, which would be a great way to learn. But for the sake of time, in this webinar, I'm just going to copy paste it. And this is the same code that was displayed on the slide as well. So I'm just going to take that code, go to the top of my current code, add it into the body here, and click Run. And as you can see now, I have 2 animations popped up, and I have a second button that says Fetch. So step 3, we're just going to make sure that the code works. And it does. My animation is hopping along the page. And then finally, step 4 is to try changing the code to our liking. Go ahead and try steps 1 to 3 before we move on. Make sure that your code works and everything is in place. Now, for step 4, let's make some changes to the code to see if we can customize it. Highlighted on this slide are some areas that can be changed that will alter the animation we have created. Take a moment to look at them, and then let's go into our editor to start customizing our animation. With my current code, I have 2 copies of the dog avatar, and I only really want 1. So looking at my code now, I have my new dog avatar and its hopping functions set right here in this code. And then I notice that I have a second image code here for that second dog. So I'm just going to delete that out, to erase that second avatar. And I'm going to click run to make sure that it's gone and that my fetch function still works. And it does. Also, there are some numbers in the code that I suspect have something to do with how the animation will look. You can change these numbers to find out what they do. It is best to change one number at a time and maybe just double it or divide it in half until you know what it does exactly. Right here in the code is where those numbers are. They were also highlighted on the slide we just showed. Feel free to experiment and change some of these to see how it changes your animation and the actions of that fetch button. So I'm just going to make some quick changes to see how this affects my code. So you can see now that some of those changes I made just changed how fast and how far or how many times my avatar moved. Take some time now to go through your code that's present in your editor. I encourage you to read through it to see if you recognize at least a few of the statements that have been added in, and to experiment to see if you know what those code statements will do. But most importantly, have some fun and make the code your own. So now that we have jazzed up our page with some basic or introductory JavaScript actions, let's see where we can go next. And that's into the language of CSS. This stands for Cascading Style Sheets. We're going to give you a sneak peek of some basic code that is used in CSS that will of course make your page even more awesome. So up until now, we have used JavaScript to change text, and we have used it to change a background color. When we change the text, we change the HTML content on the page as well. When we changed the background color, we changed a style on the page. For everything except the most basic styles, we use CSS, which is a language that was added to HTML, similar to the way JavaScript was added, as an effort to add even more style and pizzazz to the page. Background color is a part of the CSS language. CSS also includes choices for fonts, spacing between elements, border styles, margins, shadows, and many, many more. You can make these choices for your website by adding CSS either with or without JavaScript. Let's see what CSS can really do. Just to give you a hint of some of the things you can do, I'm adding some crazy styles to my page with the following code. Okay, now that I've added all this code in of CSS, let's see what it does. Whoa, how cool is that? I've added a gradient rainbow background, changed the look for all buttons, chose different font for the title, and added a dashed border and a light background for each question. This has really added character to my page, and look how sweet it looks. So we will look at the basics of CSS in our next webinar, so you can learn to make your page look more interesting, exciting, and attractive, just like I have previewed here. So thank you for joining us today. I hope you learned a lot and keep on your learning journey with text-based coding. To get a real sense of the job of coding, keep going with your STEM topic page and continue to build it out. Again, our special thanks to the Government of Canada for supporting this webinar, and look out for our future webinar on Introduction to CSS to really add in that style and flair. If you liked this content and want to make sure more of it shows up, don't forget to click that like button. Bye for now.